All right. Simplifying radicals. This was a topic that we learned a long time ago, and we're also going to learn it next week in algebra. So here's where it starts. It starts with factoring. It starts with prime factoring. All right, so I'm going to just go ahead and start. I'm going to do 9 times 10. Now, right, this radical, right, like the square root of 90 is not a whole number. If this was the square root of 100, I would be like, oh, it's 10 and I'm done. Okay, but it's not that. This is going to be an irrational number. So instead, I'm going to simplify it. And I'm going to get all the way down to the prime factorization. So this square root of 90 is the same thing as the square root of 3 times 3 times 5 times 2. Now, here's what I'm going to do. I'm going to take my doubles, and I'm going to put them in their own house. And I'm going to take my singles and leave them in their own house. Okay? Now, something magical happens with this double house, because this says 3 times 3, which is 9. And what's the square root of 9? The square root of 9 is 3, just the number 3, not the square root of 3, just the number 3, right? Because this simplifies. This is basically 3 squared and square rooted, and we know that squared and square rooted, they cancel each other out. So this whole thing just becomes the number 3. Now here, this doesn't simplify in that way, because nothing is being squared here. So I can't just square root something, right, that's not being squared, right? Here I was able to, oh, this is 3 squared and square rooted, it's just 3. But this, it doesn't simplify. So I'm just actually going to go ahead and multiply these back together. 5 times 2 is 10, and this is my answer. Okay, so we're going to do the same thing here. And I'm going to start with factoring. So this whole thing, this is the same as 5 times 5 times 2 times x times x times y times y times y times y times y. Okay? Now, let's find the doubles. Here's a double. Here's a single. Here's a double. Here's a double. Here's a double. Here's a single. Notice I had to be really neat, right? Okay, so look, let's put all the doubles in their own house. This double, this double, there's a double y and another double y, and then the singles are a 2 and a y. Okay, this is the square root of 5 squared, right? This is the square root of 5 squared. Now we know from solving equations that the square root and the squared, they cancel each other. So this just becomes a 5. This is the square root of x squared. That just becomes x. This and this are both the square root of y squared. So this just becomes a y, and this becomes a y. So that's y times y. That's y squared. And then what's left over is these singles, 2y. Okay, you're going to go ahead and try.